Welcome to Study Loop.
All right, so in this question, it's all about the combustion of propane to form carbon monoxide and water, and the delta H for the reaction is minus 2044 kilojoules. So the question is telling us that the pork roast needs 1.6 times 10 to the power 3 kilojoules, and only 10% of the heat that is produced from this reaction is actually absorbed. So, but the total amount of energy needed is this. So, what amount of energy that will be produced from this reaction would 10% of it be equivalent to this? So that will be 10% multiplied by X will be equals to 1.6 times 10 to the power 3 kilojoules. So if we find X is going to be 1.6 times 10 to the power 4 kilojoules. Okay, so that is the amount of heat that will be produced from this reaction. That 10% of it will be equals to 1.6 times 10 to the power 3 kilojoules that will be needed to completely cook the pork roast. Okay, now 1 mole of the propane produce 2044 kilojoules of heat. Therefore, 1.6 times 10 to the power 4 kilojoules will be equivalent to how many moles? So we can call that Y. So if we solve for Y by cross multiplying, Y will be 1 mole times 1.6 times 10 to the power 4 kilojoules divided by 2044 kilojoules. And Y will be 7.828 mole of C3H8. So that is the number of mole of C3H8 that need to be combusted to produce this amount of energy that will need to completely cook the pork roast. But the question wants us to calculate the mass of CO2 that will be produced from the combustion of that amount of propane. So we know that 7.828 mole of C3H8 was produced. Well, that would be needed, but from the equation, we know 1 mole of the C3H8 will produce 3 moles of CO2. So we can go ahead and say that 1 mole C3H8 produce 3 moles CO2. Therefore, 7.828 moles C3H8 will produce 7.828 times 3 moles CO2, and that will be equals to 23.483 mole of CO2. So we know that number of mole is mass divided by molar mass, and the number of mole is 23.483. Then mass will then be equals to 44 grams per mole. That's the mass, molar mass of CO2. Therefore, the mass then will be the product of 23.483 moles and 44 grams per mole. So that will be 1033.27 grams. And that will be 1.03 kilogram of CO2. So that will be the 1.03 gram of CO2 will be produced from this reaction.